Welcome to class number 77, Simple Support Beam UVL represented by a trapezium. I told you this question was solved in class number 76 by considering the loading in the same format as given, that is trapezoidal. If you remember, I told when you locate that point X, if you look this side, trapezium will come. If you look that side also, trapezium will come. So I gave both solutions. And while finding reactions, use the entire trapezium. This was last class. Now, alternate solution. Okay, written here. Don't see this one now. Solution 2. You write here. Alternate solution. Here what you will do is, instead of considering the trapezium from A to B, that is as the load is given here, we will change the loading pattern. That is, we will divide into two parts, one rectangle and one triangle. That already you know it, but write it safer side. So right here. So this is a given beam. See, A, B are not required here. This is a given. Okay, let it be A and B. At A, intensity is 36 kN per meter. At B, 12 kN per meter. What you will do is divide like this. So you get one rectangle of 12 kN per meter. Then one triangle of, this is 12 already over. This is 36, means from 36 subtract 12, you get 24 kN per meter. Now one more note you have to write. See, this rectangle, you can write rectangle also, but usually what you do, rectangle means you write UDL. So this loading will be equal to an UDL of, see, you can see here only 12 kN per meter, and uniformly varying load of 0 here to this difference is how much? 24 kN per meter. This is the beam we are going to analyze now. See, I already wrote SFD BMD for last time. Same I repeated here, because whether you divide trapezium into rectangle and triangle or multiple trapeziums, you divide whatever way you want. Whatever you do, finally SFD BMD has to come same. This is thoroughly explained last time, so we will solve now SFD BMD for this case. I decided to solve in front of you only. Okay, but this much I written. Okay, start. Calculation of reaction and support. VA, VB. Take moment about A. Minus VB into minus VB into 8 anticlockwise plus UDL. Moment of the UDL is 12 into 8 is the UDL into 8 by 2. Why I am not explaining further, plus moment of this uniformly varying load is half into 8 into 24 is the total load into the total load will act somewhere here. See, near to this side, resultant will pass somewhere here. That will be equal to, distance will be into 1 by 3 of 8 equal to 0. Therefore, you get the value of VB. I am not solving because I know the answer here. 80 plus 80 kilonewton. Plus 80 kilonewton. Okay, now sigma V0 upward positive plus VA plus VB minus the UDL 12 kN per meter for 8 meter UDL, also minus this uniformly varying load half into 8 into 24 equal to 0. You know the value of VB, substitute, excuse me, substituting, therefore you get the value of VA. Get the answer. Why should I bother to calculate? Plus 112 km. Now go for SFD and BMD with all the calculation for the beam considering UDL and uniformly varying load represented by a triangle. Now I will go for SFD BMD calculation. Just 1 minute. I'll just check the available space there. Okay, space no problem. Therefore, I will rub all this one now. I will solve in front of you only. Beam I will maintain. Beam I will maintain here. I will do one thing. I will put a dividing line here so that remaining space I can use for all the calculations. Okay, start. I wrote slightly because this is mechanical. Okay, first shear force calculation. Shear force at A, little inside you have to come, plus 112, all explained earlier. Shear force at B, slightly inside, plus 112, minus 12 into 8, also minus half into 8 into 24, you get minus 80 kilonewton. That's all. Two standard points, no other standard points. SF variation is parabolic second degree for the entire beam. Note, go back and draw SFD. Draw the SFD. 112, 80, it will come this way. Or you can do one thing. See, go up by 112, come down by this total load. That is 12 into 8 and half into 8 in 24. It will correctly come 80. I told you last time, if I draw a tangent here, intensity here is not 24, 24 and 12, 36 intensity. If I draw a tangent here, see, even if UVL has 0 intensity, but UDL has intensity. So there is intensity, so it will not be flat here. So if you draw a tangent here, I told last time, it will have slight slope. See, okay, see, slight slope will be there. It will not come like this. Little slope is there here. Okay, see, okay, I'll draw a little more neatly. Okay, now okay, see, draw a tangent here, slope is there. Now, some more thing you have to write. Go back and draw shearing force diagram. Observe the shearing force diagram. That all you have to write here. Observe shearing force diagram. See whether shear force diagram crosses baseline. Yes, it crosses baseline at a known point. So, next will be one more important point. You should write that point is required to define shear force diagram, and also we know that that is the point where bending moment is going to be maximum. Usually maximum, sometime minimum, but here it will be maximum. Okay, start. Therefore, next step, location of point, a little down I have to write because it may come out of camera. Location of point, see, between all not required, point where shear force equal to 0. Okay, now start. Let shear force be 0 at a point, see, x, comma, at small x from, now very important. Last time I told you can take x from here or x from here. But this time you have to take x from B. Write a note, why B? Because when I take a section here or consider a point here at x from here, when I look this side, I am getting triangle. Suppose you take x from here and look this side, you will get trapezium. I told you last time. Some can tell, yes, trapezium, we know it. If you know how to solve for a trapezium, then why you want alternate solution? Alternate solution is for those who find difficulty to tackle the trapezium. So, this time compulsorily from B. So, remember, B is compulsory for today's approach. Okay, start. Next, further, somewhere here, let W suffix x be intensity of UVL. Intensity of UVL at x. Now, as I told, you can enter here. No, I don't want to disturb that one. So, I will write everything once again here, sketches. So, there is a UDL here. This is to understand better only. Actually, all you can mark here only because I do not want to disturb that diagram. So, this is 24 kN per meter UVL. Now, UVL is only triangle now. So, this is how much? 12 kN per meter. 12 kN per meter. This is reaction VA equal to 112 kilonewton. Reaction VB equal to 80 kilonewton. Point A and point B. This is for complete and thorough understanding. Somewhere here, there is a point X at X from here. x from, I write down below side because I want to enter the value later. At x from here, equal later, and full span is 8 meter, not required, right? Okay, right? Full span is 8 meter. And that intensity is W, intensity W at x. Okay. Now, W suffix x equal to, as I told, 24 divided by 8 equal to W suffix x by x. These all you have to do, or mathematical class I told, using that one you can tell directly 24 by 8 into x, or equal to further 3 times x, kilonewton per meter. Enter here, equal to 3 times x, kilonewton per meter. Unit is not required, right? Understood. Okay, now next, to locate the point x, what you have to do? Equate shear force at x to 0. Or I'll start here. Therefore, shear force at x equal to. Now do one thing, you have to look this side. Why? Triangle. See, this way. You can make a note here. Look that side. Okay, look that side. Right side you are saying, when you see right side, left up is positive, right down is positive. So how many times I told, I don't know. Right up is negative. It is minus 80 plus 12 into x is the UDL. 12 kN per meter for a length of x is the total UDL. Then also plus this much load, half into x into this intensity is 3 times x. See, to understand clearly, I am using red color for x. This should be equal to 0. Or you get 3 divided by 2 is 1.5 times x square. Then plus 12 into x minus 80 equal to 0 is the quadratic equation to solve. Solving, we get x equal to, this time I am not solving because I am 100% sure you know the answer. 4.3267 will come. It has to come. It will come 4.3267 meter. One statement. Therefore, shear force is 0 at 4.3267 meter from B. And that is the point where bending moment is maximum. Now, substituting x equal to, why you require it? For BM calculation. X equal to 4.3267 meter. You get the intensity at x, that point x equal to 3 into, where is it? Here, 3 into x, 3 into 4.3267 equal to 3 into 4.3267 equal to 12.98. 12.98 kilonewton per meter. 98 kilonewton per meter. Right. Note. Go back and enter. Enter. This is a note you are right. Come back here. Write x. 4.3267 meter. Calculated value is 3x equal to 12.98 kilonewton per meter. 1 minute. Last time, when I consider that point x, intensity you would have got 24.98 kN per meter. Why? Because it was 24. Now, of the 24, 12 is already UDL here. So, remaining is only 12.98. So, 12.98 plus 12, if you add these two, you get back that 24.98 you got last time. Check it. Oh, lastly, BM calculation. Over question now. BM calculations. Sagging positive. Standard point first. BM at A equal to 0. BM at B also equal to 0. I told you not over. Also, you require BM at that point x. BM at the point x. I told reason you have to write if you want. This is the point you should write right here. This is the maximum BM because this is the BM at the point where shear force is 0. All these things are told. So referring to earlier class, if you want to gain a perfect knowledge or everything I tell, make a note. It will become bulky, but any time in future when you want to refer, you can refer, understand. Otherwise, I have seen something told in the morning, by afternoon, forgotten. That I have seen all these days, I am seeing that one. Those who study thoroughly and make all the notes and show full dedication, they only will become master. Okay, start. BM at x equal to, look this side, plus 80 into, equal to plus 80 into 4.3267 minus 12 into 4.3267 is the total UDL into 4.3267 divided by 2. Lastly, moment of this triangle load minus half into x is half into 4.3267 into that height is 12.98 is the total load. Why I am not explaining? Because explained I can tell infinite times. When something is explained more than 10, 15, 30 times, I need not explain. Into see, moment about this point, this load will act here. This distance you want is 1 by 3 of 4.3267. Just 1 minute. I will check the camera there. Should not go out of the camera. Okay, perfectly okay, no problem. Everything is there. This time I am not going to calculate. If I calculate, that is, people will tell he has no confidence. 193.316 plus 193.316 kilonewton meter. It is my own value. I have not copied from anywhere. Over. Now, lastly, closing part, right, BM variation. BM variation is parabolic, third degree, right, third degree. Lastly, right, go back and draw BMD. Draw BMD. See here, 0, 0 here, 193. Here slope is lesser because shear force is 80. Here slope is more. All I told earlier. So BMD is over. This will complete uniformly varying load represented by a trapezium. We covered both the cases. Left side minimum, right side maximum, earlier classes. Right side minimum, left side maximum, this class. Class number 78, I will go for combination of point load, UDL and UVL. In case of UVL, I may put sometime trapezium, sometime triangle. Now onwards, random questions. Random means just I will tell 70. I will note in 78 class. Now from 78 up to few classes, heading is simply support beam, bending moment diagram for simply support beam for combination of all type of loads. I will put combination of all type of loads. Many questions I will solve. But all the questions, most probably before starting here, I may write something because you know it now. Anything important, I will explain. People who want to get thorough knowledge, start from class number 1 and reach here and then see where is your knowledge level. Okay, we will meet in class number 78. Thanks.